welcome to our channel. Today we're diving into the dark side of science with 10 horrifying facts that will keep you up at night. From the relentless expansion of the universe to the mind-bending concept of the simulation hypothesis, we'll explore the most unsettling scientific phenomena that challenge our understanding of reality. Discover the terrifying potential of supervolcanoes, the looming threat of antibiotic resistance, and the catastrophic power of gamma-ray bursts. We'll also delve into the ultimate fate of the universe, the enigmatic nature of black holes, and the perplexing Fermi paradox. Each topic will not only fascinate you, but also leave you questioning the very fabric of existence. So buckle up and prepare yourself for a thrilling ride through the darkest corners of science. By the end of this video, you might find yourself pondering the fragility of life and the vast, unpredictable universe we inhabit. Let's embark on this journey together and uncover the 10 horrifying science facts that will keep you up at night. Imagine looking up at the night sky only to realize that everything you see is moving away from you at an accelerating pace. This is the reality of our expanding universe. Discovered by Edwin Hubble in the 1920s, the concept of an expanding universe was revolutionary. But what's even more unsettling is that this expansion is accelerating, driven by a mysterious force we call dark energy. Dark energy makes up about 68% of the universe, yet we know almost nothing about it. As galaxies move further apart, the universe will become increasingly cold and dark. Stars will burn out, galaxies will drift away, and eventually, the night sky will be devoid of the twinkling lights we're so accustomed to. The fabric of space-time itself is stretching, and one day, distant galaxies will be so far away that their light will never reach us. This isolation could mark the end of our ability to observe and understand the universe beyond our local group of galaxies. The universe is a place of wonder and terror, and its relentless expansion is a stark reminder of our place within it. Beneath the serene landscapes of our planet lie ticking time bombs known as supervolcanoes. Unlike regular volcanoes, supervolcanoes have the potential to unleash eruptions thousands of times more powerful, with catastrophic global consequences. The most famous supervolcano is the Yellowstone caldera in the United States. While it's a popular tourist destination, it's also a sleeping giant that could change the course of human history. A supervolcano eruption would spew vast amounts of ash and sulfur dioxide into the atmosphere, blocking sunlight and causing a dramatic drop in global temperatures. This phenomenon, known as a volcanic winter, could last for years, devastating agriculture and leading to widespread famine. The last supervolcano eruption occurred about 74,000 years ago at Toba in Indonesia, and it's believed to have caused a severe bottleneck in the human population. The ash from a supervolcano eruption would also pose a significant health risk. Inhalation of volcanic ash can cause respiratory problems and even death. Infrastructure would be buried, and the economic impact would be staggering. The interconnected nature of our global society means that the effects of a supervolcano eruption would be felt worldwide, disrupting trade, travel, and daily life. Scientists are closely monitoring known supervolcanoes for signs of activity such as ground deformation and increased seismic activity. However, predicting the exact timing of an eruption remains a challenge. The potential impact of a supervolcano eruption extends beyond immediate physical and environmental damage. The threat of supervolcanoes is a sobering reminder of the dynamic and sometimes perilous nature of our planet. In the age of modern medicine, antibiotics have been a cornerstone in the fight against bacterial infections. However, the overuse and misuse of these life-saving drugs have led to a growing crisis antibiotic resistance. Bacteria are incredibly adaptable organisms, and over time, they have evolved mechanisms to survive even the most potent antibiotics. This resistance threatens to undermine the effectiveness of treatments that we've relied on for decades. The rise of antibiotic-resistant bacteria, often referred to as superbugs, poses a significant threat to global health. Infections that were once easily treatable are becoming increasingly difficult to manage. Common illnesses like pneumonia, tuberculosis, and urinary tract infections are now harder to cure, leading to prolonged illness and higher mortality rates. The World Health Organization has identified antibiotic resistance as one of the biggest threats to global health, food security, and development. Medical procedures that rely on antibiotics to prevent infections, such as surgeries, chemotherapy, and organ transplants, are at risk. Without effective antibiotics, the success rates of these procedures could plummet, leading to higher complication rates and longer recovery times. The economic burden of antibiotic resistance is also substantial, with increased healthcare costs and lost productivity. Resistant bacteria can transfer their resistance genes to other bacteria, creating new strains that are even harder to combat. The widespread use of antibiotics in livestock farming has also contributed to the problem, as resistant bacteria can spread from animals to humans through the food chain. Reducing the overuse and misuse of antibiotics is crucial, both in human medicine and agriculture. By working together, we can develop strategies to combat resistance and preserve the effectiveness of these vital drugs for future generations. Imagine a burst of energy so powerful that it could outshine an entire galaxy in mere seconds. This is the terrifying reality of gamma-ray bursts, or GRBs. These cosmic explosions are the most energetic events in the universe, releasing more energy in a few seconds than our sun will emit in its entire 10 billion-year lifetime. GRBs are thought to be caused by the collapse of massive stars or the merger of neutron stars, resulting in a cataclysmic release of gamma radiation. The sheer power of a gamma-ray burst is enough to cause widespread destruction if one were to occur close to Earth. The intense gamma radiation could strip away the ozone layer, leaving the planet vulnerable to harmful ultraviolet radiation from the sun. This would have devastating effects on the environment, including increased rates of skin cancer, damage to crops, and disruption of marine ecosystems. While GRBs are incredibly powerful, they are also relatively rare. Most occur in distant galaxies, far enough away that their effects are not felt on Earth. However, the possibility of a nearby GRB is not entirely out of the question. Scientists have identified potential candidates within our galaxy that could produce a GRB, although the odds of one occurring in our lifetime are low. One of the challenges in studying GRBs is their unpredictability. They occur without warning and last for only a few seconds to minutes, making them difficult to observe and analyze. The immense power and unpredictability of GRBs serve as a reminder of the dynamic and sometimes violent nature of the universe. The concept of the heat death of the universe is one of the most chilling and final scenarios in cosmology. It refers to a state in which the universe has reached maximum entropy, with no thermodynamic free energy left to sustain processes that increase entropy. In simpler terms, it's the point at which all energy is evenly distributed and no work can be done. This marks the end of all physical processes, leading to a cold, dark, and lifeless universe. The idea of the heat death stems from the second law of thermodynamics, which states that the total entropy of an isolated system can never decrease over time. As the universe expands and ages, it moves towards a state of higher entropy. Stars burn out, galaxies drift apart, and black holes evaporate, leaving behind a vast expanse of empty space. The universe becomes a cold, dark, and desolate place, devoid of any form of life or activity. The timeline for the heat death of the universe is mind-bogglingly long, spanning trillions of years. Long after the last stars have burned out, the remaining matter will continue to decay, and black holes will slowly evaporate through a process known as Hawking radiation. Eventually, even the most stable particles will decay, leaving behind a universe filled with low-energy photons and neutrinos. While the end may be trillions of years away, the journey towards understanding our universe and its fate is a fascinating and humbling endeavor. The concept of the heat death serves as a reminder of the vast, unpredictable, and ultimately finite nature of the cosmos. Black holes are among the most mysterious and terrifying objects in the universe. These regions of space are so dense that not even light can escape their gravitational pull. Formed from the remnants of massive stars, black holes challenge our understanding of physics. The event horizon marks the point of no return. Once crossed, objects are drawn to the singularity where physics breaks down. The immense gravitational pull warps space and time, creating spaghettification. Close to a black hole, you'd be stretched into a long, thin shape. This process would be fatal, illustrating the deadly nature of black holes. Black holes can consume entire stars and planets. Stars torn apart by tidal forces create spectacular displays of energy. Despite their terrifying nature, black holes play a crucial role in the universe. They are believed to be at the centers of most galaxies, including our own Milky Way. The Fermi paradox is one of the most intriguing questions in the search for extraterrestrial life. Named after physicist Enrico Fermi, it questions why we haven't found evidence of extraterrestrial civilizations despite the high probability of their existence. In a universe with billions of stars, why haven't we found any signs of intelligent life? Possible explanations include the rarity of intelligent civilizations, or their avoidance of contact. It could mean we are one of the few intelligent species in the galaxy, or advanced civilizations may be uninterested in making contact. Another unsettling possibility is that they self-destruct before establishing contact. The search for extraterrestrial life continues, with efforts like SETI scanning the skies for signals. Until then, the question of whether we are alone remains one of the most profound mysteries.